Good evening and welcome to See You at USC. I'm your host, Jill Schneiderman, and tonight I am joined with Dr. Khoshnevis of USC and an amazing inventor. Thank you so much for being here.
Thank you, Jill.
I'm really excited about this show because I'm going to admit it right now, I know virtually nothing about the subject we're talking about, and I'm very excited to learn. You are the inventor of contour crafting, which has had, I'm telling you this, you obviously know, world-renowned fame. Please tell us, for the non-engineers in the room, what exactly is contour crafting and how is it going to change home building?
Contour crafting is a method of fabrication. Throughout the history, we have come up with a number of different ways of building things. But two separate cultures have developed in fabrication. One is called manufacturing, when basically objects are built within a factory, usually numerous numbers of the same kind of object with same designs, like your cars, for example, or home appliances are built in a factory setting. And another culture deals with construction of very large objects, mainly civil structures, homes, and there the production resources, that is people and tool, go to the site of the product rather than taking the product to where the production resources are. So because of these, and also because of the nature of the materials used and the scale of fabrication, the two cultures have been treating their professions very differently.
Which is used to build the average home in the United States?
Well, of course, the construction technologies, which is highly manual. Really, in the last 20,000 years, we have not advanced very much in construction, while, as you know, we have advanced greatly in manufacturing. Today, almost everything you see is made fairly automatically, using automated processes, some of which use intelligent robotics. However, as you can notice, construction industry is relatively backward as it comes to technology usage.
So contour crafting then, we'll get back to that now. What does that do?
Well, contour crafting is a generic fabrication technology. My background is actually manufacturing. I am not a civil engineer or architect or construction engineer. Prior to getting involved in this project, I knew very little about buildings.
Wow.
So I invented a process for building 3D objects directly from computer models in a layer-wise fashion. I have other inventions in the same field, and there are also inventions that are contributed by other inventors in the last 20 years in the field of layered fabrication, building objects layer by layer. The difference in contour crafting is that it's the only fabrication process that is scalable. That is, by increasing the size of the object, the time does not go up exponentially, it goes up linearly. Therefore, it is feasible to build very large objects in a very reasonable time. So initially my thought was, after building large industrial molds and industrial objects, I wasn't thinking about buildings. I was using materials that were like plastic, thermoplastics, thermosets, really targeting industrial applications. But I decided to try more varieties of materials because the process was very forgiving with respect to the choice of materials. So I gradually moved into trying plaster, trying to clay, and eventually concrete. And then it became obvious to me that the process can actually be used for building civil structures.
How much time are we talking about saving here from the way a normal house
we are
is
talking
built?
about a process that is about 200 times faster. Usually right now it takes about 6 months to a year to build an average home in the United States, which is a fairly advanced industrial country. In contour crafting, with contour crafting, conceivably we can build a whole average, this 2,000 square foot house with all the electrical and plumbing embedded and even painted with wallpaper designs in less than 24 hours. This is 200 times faster. The quality will be extremely better. It will be computer controlled machinery. It has a quality of like your cars, the way they're made. Accuracy and reliability and quality will be much better.
So are there any houses right now currently that are built this way?
No, we are just at the beginning of a new era in construction automation, and contour crafting is really starting this era. We have built stuff at the small scale, and we have built full scale wall sections. As soon as we built the first wall section, the news about contour crafting capabilities really spread throughout the world quickly.
And you really have gotten unbelievable press about this.
Yes, it's understandable why, because construction typically is the largest sector of every economy.
Yes.
It is in the United States. Last year it was nearly $1 trillion. Therefore, any impact that you make in the field is going to translate to a lot of dollar values.
Oh, certainly.
And
200 times faster is going to be many dollars are going to be earned that way. What I would love to do, we have to cut to a quick commercial break, but when we come back, I think seeing is going to be believing, and we're going to see some actual computer-generated models of how contour crafting works. So stay tuned. You will not want to miss this. I'm Jill Schneiderman, and you're watching See You at USC. Stay tuned. I'm your host, Jill Schneiderman. I'm joined with Dr. Khoshnevis. And if you want to contact us at CU, you can do so by emailing us at cu@trojanvision.com, or you can call us at 213-743-4178. So Dr. Khoshnevis, thanks again for being here. And when we left, we had just gotten into talking about how we would like to actually see how contour crafting works. So I'd like to go to a clip of exactly how this all works, and then we can talk through it so you can explain it to everybody.
Sure.
So let's see that right now.
Well, as this animation shows, the process uses a nozzle assembly which extrudes multiple materials.
Okay.
At each extrusion orifice, there is a trowel, a planar surface that smooths out the extruded material. The material used for the shell of these wall structures could be a plaster-like material which sets very quickly and has a nice appearance, but it does not have to necessarily have structural strength. The filler material that goes inside, however,
that needs to be strong.
Right. It could be like a concrete, cementitious material. As you see,
is this a robot actually doing all this? It'll be a robotic assembly line. Won't be a person that does this.
That's right. You just take this machine to the site and quickly set it up, and then the architectural design is inputted to the system, and from that design, the order for the toolpath is generated, and the machine is controlled by a computer. As you see, the system can embed conduits, that is open volumes for embedding plumbing and electrical modules as well. So this nozzle assembly is mounted on a gantry robotic system, which I'll show in the last animation.
Oh, well, okay. Watching this, the only thing that I can think of over and over is, how do you think of this? Are you sitting down at breakfast one day and you're saying, building houses is way too difficult, I'm going to fix that? How does that come to you?
Well, it is really complicated to trace the origin of an invention. It's a multitude of ideas and circumstances that lead into an invention, and of course the time for it has to be ripe as well. This invention couldn't have been conceived 67 years ago because computer automation was not that advanced. It really couldn't have been convinced probably 30 years ago because people had not started thinking about layered fabrication technology using computers. So after the advancement of these two different fields, the situation was ripe, and the idea would have been crystallized, if not by me, maybe in a few years by somebody else.
But how did it get to be by you? Was there a precipitating factor that just clicked
Well, I
in
can
your
tell you
head?
the circumstances that contributed partially at least to this. In 1994 Northridge earthquake, we got a crack on the living room, like most houses in LA area. I decided to fill that gap by buying some plaster and a putty knife. And as I was filling that gap, it occurred to me that this simple tool, the trowel, which is a simple metallic blade, has such a powerful capability in forming surfaces. And in manufacturing, we are very much always after creating smooth surfaces, nice surfaces, because they typically reduce friction, like in your car, the piston and cylinder running against each other thousands of times an hour. Smoothness matters a lot, therefore the machining processes that are there. So anyways, I looked at the manufacturing process, and not a single one uses trowel in an automatic way.
So this is very relevant for Californians. Is contour crafting in-house building a more earthquake-proof way to build your home?
Well, you can build any structure to be more earthquake-proof by putting more strength into it. In contour crafting, the cost of construction